Hi everyone. So somehow it's not streaming, and that's been so I am just going to figure out where is this streaming. Uh, it's very strange. Oh, it is streaming now. Hi everyone. Okay, so can you guys see me? You should be able to see me. I am live now, and we will be solving the latest paper. So if you guys are connected on chat, say hello. The thing with directly doing on YouTube is there's a chat delay of about 10 seconds. Okay. So when you ask me the question, it'll take about 10 seconds for me to even hear it. So sometimes it look like I am talking ahead of you, but really it's just a time delay. Okay. So that's what we have to begin. Yeah. All right. So I'm going to share my screen now. I hope you guys can see this also. This is my screen with the paper. And we're going to start out with question number 1 first. Okay. Can you guys hear me, by the way? Can you hear me? I hope you guys are only hearing one audio. I got 2 audios out of me, so I'm just wondering. Is anybody connected? Can you guys confirm this, please? Because it's strange I'm hearing 2 voices. Hence, I wanted to check in with you. Yeah. So we have some of you watching right now. Could you guys confirm? Is anybody available on chat? Can you guys hear only one audio or 2 simultaneous audios of me? Hi. Wow, somebody is excited. Noodle arms. So I'm just wondering if you guys can hear me as one audio. One audio, that is perfect. Sorry, the delay is always going to be there, but I'm going to start now. So, hi everyone. You see me? You see me? Okay, so let's begin the first question. So now we can also, by the way, do questions in different orders depending on which ones would you guys like me to try out first. Let's start with question number 1 first, and then you can change audios. Okay, so here, if we see this particular paper, this is talking about choose from the following salts. So we got certain salts here. We got aluminum sulfate, which is Al2SO4 thrice. I'm just practicing the formulas. Barium chloride, copper nitrate, and copper sulfate. Copper salts tend to be blue in color. Magnesium chloride, potassium iodide, which is a good reducing agent. Potassium manganate is a good oxidizing agent. Silver chloride and silver bromide are insoluble, white and cream. Now, so just to talk about the questions, you got for example here, most of them are soluble, but the last 2 are insoluble salts. And so it seems to be, yes, we're only doing paper 2 right now. Paper 22, which is prepared by using a precipitation reaction. So here, what is prepared using a precipitation reaction? Insoluble salts. And so basically, either you can say I can state, now they said state, so I can write the name or I can write the formula. So I can say silver chloride or even silver bromide, either or. Can be. Oh, that's sodium bromide. My bad, guys. So sorry. Okay. So that's the last one. Why am I reading too fast? So it's silver chloride is insoluble. Sodium bromide is not insoluble. Please. It's NaBr. It's got the sodium ion, which is what I need for the second part. Thank you, Noodles. I got it. Yeah. So it's only sodium, silver chloride. Now, the yellow flame is of the sodium ion. So in all this list, that would be wherever there is sodium. I think we only have one sodium. Sodium bromide. You know what started today? I'm so happy. Formula 1 started again. So I watched that race. That was pretty nice and lots of fun, by the way. Yeah. So I had my good time. Anyways, it was a good first race of the season. I don't know if you guys watch it, but you know. Then it says dissolves to form a dark purple solution. There's only one dark purple solution we know of, and that's KMNO4. Or you can write the full name, potassium manganate 7. Either or. Because the question was state. So you can state the name or the formula if you would like. And then has an aqueous solution that reacts with sulfuric acid to give a white precipitate. Sulfuric acid has a sulfate anion. So which cation forms a white PPT with sulfate? Do you remember that? It has to be the barium cation. Because this is now salt from the lab, the ion test. So knowing that barium forms a white precipitate with sulfate helps you figure out that I'm looking for a barium salt. And the barium salt they have here is barium chloride. And then it says has an aqueous solution that reacts with aqueous bromine. Now something that is less reactive than bromine. So bromine has to be more reactive here. This is about group 17 halogens. So when bromine is more reactive, it has to be a less reactive. So what that means is it has to be lower than bromine in group 17 or group 7, which is iodide. Hence the CAIE salt, or whose name is potassium iodide. Now understand these questions are actually pretty easy. They just, I think, give you a breadth of areas of the syllabus to test you out from. Other than that, they don't seem to be pretty difficult. But yes, they test your knowledge across the whole syllabus more than anything else. And there are not too many marks for this most of the time, so that's pretty much okay, you know. Anyways, so moving on, let's do the next question. Okay, so there's some bonding and electrolysis questions, some organic. Would you prefer I do organic first or do the next question? The next question is bonding and electrolysis. Then there is enthalpy changes and rates of reactions, and then you got organic. So because I don't think we'll be doing the whole paper in class, so choosing the right order questions might help you do them. Because if you have any questions for what we did and also the direction in which the next question should be. I was really thirsty. Okay, let's do the next question. Bonding. Rav Breka says let's do the next question first. Okay, so what do we have next? A dilute aqueous solution of magnesium chloride is electrolyzed using graphite electrodes. Now graphite has a high melting point and is inert, so it's a good electrode for that reason. Now why does graphite have a high melting point? It's about its structure and bonding. Now graphite is a giant molecular structure held by now this is the bonding and structure for graphite. Now the alternate is it could have also been a simple molecular structure held by covalent bonds, but the problem is in simple molecular structure you do not need to break covalent bonds to melt, but a giant structure, and so it's to melt it you need to break the strong covalent bonds that require lots of energy, which because they're strong covalent bonds they require lots or large amounts of energy. Lots of energy or large amounts of energy versus a simple molecular structure like iodine or bromine or chlorine, is that they have covalent bonding like oxygen also, but you don't need to break covalent bonds because you can break the van der Waals forces there because they have weak van der Waals forces. Here they do not have any weak forces, the only forces they have are strong covalent bonds. And then step 1 of the profit that makes it suitable for an electrode. So it's high melting point and it conducts electricity. That's the second property it needs to use. It conducts electricity. And if I have dilute aqueous magnesium chloride, now we get electrolysis. So it's aqueous, right? At the anode you got the anions and the cathode you got the cations. Because the cathode is magnesium, the cations are magnesium and hydrogen, it's the hydrogen that gets displayed. Unless you have copper, every other metal has a lower discharge than hydrogen, so hydrogen gets discharged. And at the anode, if chlorine was concentrated, it would be chlorine, but it's not, so oxygen gas is discharged. Remember that, oxygen gas, because this is dilute. If it was concentrated, then chlorine would have deposited first. But now when you have molten, you have no choice. The only cation is aluminum 3 plus and the only anion is oxygen. That's it, there's no other choice. So at the anode, O2 minus becomes oxygen. So O2, so 2 of these, 2 times 2 is 4 minus, so you can put 4 electrons here. And then Al3 plus has to become aluminum. So and is 3 plus becomes 0, so you got to add 3 minus to it. That's how I got to balance the charge. The other thing is at the cathode you have reduction, and anode you have oxidation. Oxidation is loss of electrons and reduction is gain of electrons. And these are things that you can do easily. There's very common reactions to give electrolysis. It's a way of identifying redox reactions and the charges on the ions. So they kind of like that stuff. So they've given dilute in one go, molten in one go. Also they've also given electroplating, because in this case the cathode is the metal object and the anode must be copper, because the anode dissolves to electroplate. So if you are electroplating with copper, then the copper has to be anode. So the anode has to be pure copper, and the electrolyte has to have any copper solution. So you could say aqueous, you could say either the electrolyte is copper sulfate aqueous, which is the most popular one. You could also have taken copper nitrate if you want. It doesn't have to be copper sulfate, but because copper sulfate is the most popular one we use, you know, we end up using that. Alrighty. Okay, I'm just playing with the stuff. Okay, anyways, so any questions you have before I go to the next one, please? Yeah, I'm just playing with my live stream. Come on. Or I should just do the next one, which is enthalpy changes. I know I'm just messing with my screen, so yeah, let me know. Next one is this, and after that it's organic. So if I want to have, I'll be good with this. Yeah. Okay. So the third question is the equation of reaction between ethene and bromine is shown. Ethene is an unsaturated hydrocarbon, so that's its homologous series, so that we can, you know, see what's going on. Okay. And bromine, and this is now a halogenoalkane. So describe the observation when it's bubbled through aqueous bromine. Now aqueous bromine's color initially is orange. Liquid bromine might be red brown, aqueous bromine is orange. And so it goes from orange, and this fellow is colorless. All organic compounds are colorless. So what you say is it goes from orange to colorless. Don't just write decolorized. You can say the orange solution is decolorized, but orange to colorless is what they're looking for. Okay, this is not ethyl bromide. I would not call this ethyl bromide, guys. Think of it as an alkane now. It's got 2 carbons, so it's ethane, but it's got 2 bromines, so it's dibromoethane, and they're on positions number 1 and 2. If anybody is wondering what this is called 1,2-dibromoethane. So it went from ethene to 1,2-dibromoethane. If my writing is a little messed up, ethane, sorry. No, well, somebody is asking, can you write purple to colorless? Well, if something is going from orange to colorless, can you write it goes purple to colorless? Unless in your world purple and orange are the same exact color. I mean, how is it the same exact thing? If something is orange and is becoming colorless, do you think you could write purple to colorless? Might as well write pink to colorless, or orange to green, or like blue to smoky, or like, then anything goes, right? If it's only one particular color, how could you write other colors? It's like, it doesn't make sense. Bromine, aqueous, is orange. It has no other color. Aqueous bromine is orange, no other color. KMnO4 is purple, and that's not what being used here. So, you know, now they're saying show by calculation the enthalpy change of the reaction between ethene and bromine. So here what I do is I've got to figure out what's breaking and what's forming. So now look at the question here. What you might recognize is that the changes are a carbon-carbon double bond is becoming a carbon-carbon single bond, and a bromine bond is becoming a carbon-bromine 2 bonds. So when you think about it, a carbon-carbon double bond is being broken, a bromine bond is being broken, and what is being formed? A carbon-carbon single bond and carbon-bromine, 2 of them are being formed. So that's what I'm going to use, by the way. Bonds broken, bonds formed. So I'll write again, bonds broken are one carbon carbon double bond and one bromine bromine. Bonds formed are a carbon carbon double bond becomes a carbon carbon single bond, and you cannot say, oh well, a single bond is broken. No, a double bond is broken to form a single bond is completely different. You cannot say a single bond is broken. No, that's separate. This is a double bond is broken to forming a single bond, and two carbon bromine bonds are being made. So now do the math here. Remember, delta H is bonds broken, which is an endothermic reaction. Bonds broken are CC plus BR minus CC and single bond and two CBRs. So what is a CC double bond? 610 and BR 193. And what is being formed? CC and two CBRs. And I'll do that math, and what do I get? (910). This should give you minus 107 kilojoules per mole. That's a good 3 marks. Bonds broken is endo and bonds formed is exo. Then it says complete the reaction pathway for the reaction in ethane and bromine. You got to have reactants, products, enthalpy change, and activation energy. Because the reaction is exothermic, you can do it like this. The reactants, products, something like that, and from there to the highest point, maybe I can make it even higher. Come on. It gets stopped in the middle. Why is it getting stopped in the middle? This is annoying. Okay, maybe this is better. And then what do I have? From here to the highest point is EA, and from reactants to products is delta H. It's everybody who can draw this. It's like a common thing. You can't go wrong with just being able to draw the delta H for any reaction. Yeah, I believe anybody can do that. It's not a rocket science, but this is stuff that comes quite often. These are not questions that are out of the blue. This comes almost regularly. Making an energy profile diagram, and you're labeling everything here. Yeah, it's a good 3 marks. They're given away. They're given away. They're given away. And now the last bit is they want to draw the dot and cross of ethene. So now they're testing some bonding also, because you know ethene is a double bond between carbon and carbon. So I have ethene. I will duplicate this. So I have two ethene, two carbons, and then I have hydrogens. So to make my life easy, I'll make one hydrogen and I will just duplicate it. Duplicate, duplicate. You can make it anywhere you want. I like them as like this. You can make it up and down, up and left. I like it like this. So you got the carbons and you got the hydrogen. So the carbons are for me dots, and the other, or so if the carbon is dot, each carbon is dot. They're the same dots. That's fine. Carbon, 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 carbon. And for me, hydrogens are crosses. So cross, 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 cross. You can make a label if you want, but nobody really cares. Yeah, we'll do some more. Yeah. So far, okay? Now this is what we have now. The next question is organic chemistry. Yeah, so do we do organic next? Yes, we do. We do. We do. So, I am lovable. I can't help it. Okay. Moving on. Now, this is ethanoic acid. Ethanoic acid is a member of the homologous series of carboxylic acids. What's the general formula for carboxylic acids? It is CN H2N plus 1 COOH. Now, one characteristic of a homologous series is that all the compounds share. This is for, by the way, carboxylic acids. CnH2n COOH. Okay. You get all, for alcohols, it is CnH2n plus 1 OH. For alkanes, it's CnH2n plus 2. For alkenes, it's CnH2n. You should have learned these. What do you call it? These general formulae. Then it says one characteristic of a homologous series that all the compounds share similar chemical properties. Now, why do they have the same similar chemical properties? If they have only one thing that makes them have the similar chemical properties, do you know what that is? That is the fact that they have the same, you can say, they have the same functional group. Okay, that's why they have the same chemical properties. What's another definition of homologous series? They have the same chemical properties. You can have they can have a general formula, and consecutive members differ by a CH2 group. And then you have another reaction. This is between calcium and ethanoic acid. So it makes a salt. What is this salt called? It'll be called calcium ethanoate. That's what it will be called. The salt of ethanoic acid is ethanoate. So remember that. Now, the reason why they have same chemical properties is not that they have this general formula. They are the same functional group. And that's, you can put them in a general formula, but the functional group is what's responsible for the similar chemical properties. Okay. Then you have something else. A sample of 1.35 grams of calcium is added to excess ethanoic acid. Excess. So this is limiting. And you know that 1 mole of calcium, look at the formula on top. Uh-oh, my bad. So you have 1 mole of calcium makes 1 mole of hydrogen. So what I'm going to do is I'm going to find the moles of calcium, which is the mass over atomic mass of the element. So I have 1.35 divided by 40 is the AR of calcium. This comes out to 0.03375 moles. Then the mole ratio of calcium to hydrogen is 1:1, which means the number of moles of hydrogen gas is also 0.03375 moles. And in my third step, I will convert this into volume. So then I need the volume formula. Volume of any gas is the number of moles of gas into 24 dm cube. So I have 0.03375 into 24 dm cube. And here I will need my formula, my calculator, sorry. But then I bought a new calculator and realized that all these new calculators are, I've gotten the Delhi one. There's the Chinese. And I can't seem to find the, what you call it, the Casio ones are no longer that available, which is so strange. I mean, these are much better at the lower price. So, you know, this comes out to exactly 0.81 dm cube. Easy peasy, lemon squeezy. And now you got to make vinegar. Vinegar is what? Describe the manufacture of vinegar. Basically, vinegar forms on the oxidation of ethanol. Ethanol gets oxidized to make vinegar. So what you do is this basically, and in everyday life, bacteria oxidizes it. So you take ethanol. Yep, you guys got that. So naturally, vinegar, not in the lab, naturally you take ethanol, reacts with oxygen in the presence of bacteria. What does bacteria do? It is a catalyst. It catalyzes it to make, so ethanol and oxygen are the reactants and bacteria is the catalyst, which is a condition to make vinegar. Pretty simple stuff. Alrighty. Yes. So, any questions so far? Otherwise, I'm going to move to the next part. Now, in the next part, it says butanoic acid. So butanoic acid is 4 carbons, so it's 3 carbons and COOH. And then you got to write the molecular formula for it. So that's 4 carbons and 8 hydrogens and 2 oxygens. That would be the molecular formula. Propanoic acid has 3 carbons. So it is C2H5, because the third one is COOH. So that means I need to have C, O, H, which means I've got to show them the first carbon is CH3, and then I have CH2, which makes C2H5, COOH. This is the displayed formula of propanoic acid. All right. And then sodium carbonate is added to propanoic acid. Remember, carbonate and acid form carbon dioxide, salt, and water. So what's one observation? They just want one observation, you know. And because it's carbon dioxide, you can say there is effervescence. I know I wrote it right, but I just want to clarify it. Effer, VESCENCE. Effervescence of a colorless gas. That's it. That's one observation. If they want another one, you can say it forms a colorless solution, and the solid dissolves, the carbonate dissolves. But they wanted one only, so effervescence of carbon dioxide. Effervescence of carbon dioxide. Now, when sodium hydroxide is added to butanoic acid, it only forms a salt and water. The salt is sodium butanoate and water. So the salt is, sorry, somehow my pen started acting up. Sodium butanoate and water. That's what you have. Alrighty. That's this question. I'm just solving these questions as they come. But if there are any questions, you can ask. Okay, so the next question, since nobody's asking anything, I'm going to move on to the next one. It says the combination of fossil fuels is used to power stations. And I'm just going to relax just a little bit. I don't know how that looks on. Yes, okay. So this says one compound diesel has the formula C12H16. Construct the equation for the complete combustion. So C12H26 plus O2 will make 12 CO2 and 13 H2O. And the oxygens, I can do it by the formula if I want. Or which is X plus Y by 4. Or I can just add them up. So if I do the formula, it's 12 plus 26 over 4. So what is 26 over 4 in a calculator? If I do it, is 6.5. So 12 plus 6.5 is 18.5. So yes, I can write 18.5 or 18 and a half O2. I can write this. I can also say 2 and then whatever, this is 37, 24, 26, but that's up to you also. Muddak, you can write that if you want, but that's not naming the product. That's giving the formula. You can give the formula also. Absolutely correct. You can do that. There's nothing wrong with that. Okay, so that's the first bit. Now state the complete combustion of C12H26 producing an air pollutant. Now what's an adverse effect of this air pollutant? In a complete combustion, the air pollutant is carbon dioxide. What's an adverse effect for carbon dioxide? It leads to global warming. Or the new name for global warming is it affects climate change. But either or is fine. You can write either or. And then it says, explain how diesel oil is separated from petroleum. So now this comes what? This is the fractional distillation. Now I don't feel like writing all the time, so I'm assuming if I say it, you guys can write it. Distillation. So basically what you do is you carry out fractional distillation of petroleum by heating it and using a fractionating column. And what happens is diesel is collected at the boiling point of diesel, because all the other components of petroleum will be separated due to their boiling points, and that's what you will write. Cheyenne, 2 mole, then 13 mole, then 26 mole, then greenhouse effect. Global warming, yeah. Cheyenne says, okay, you have that 2, then 37, then 24, and then 26. Yeah. So I'm not going to write it, but you know what I'm saying, right? Apologies, there's a delay in YouTube, so when I'm already in the next part of the question when you guys are commenting on the previous part. But if I stop for everything, yeah, it's on the basis of varying boiling points. So what happens is different components separate based on different boiling points, because you heat petroleum in a fractionating column. All the different components, including diesel, get separated because of the difference in boiling points. Yes, Sayan, that is exactly what you would write. Absolutely. Now, sulfur dioxide is removed from the emissions from a power station using calcium carbonate. What's one adverse effect of sulfur dioxide as an air pollutant? Because sulfur dioxide can cause acid rain. We know sulfur dioxide can be oxidized to sulfur trioxide, which can then react with water to become sulfuric acid, which is what acid rain is. Yes, Sayan, heavier at the bottom because they have higher boiling points, and the one with the lower boiling points are at the top. Absolutely. So 1 mole of sulfuric acid, sulfur dioxide, reacts with 1 mole of calcium carbonate to make 1 mole of carbon dioxide. So now they want the equation. So they're saying SO2 plus calcium carbonate becomes carbon dioxide. So what's left? Calcium oxide, C. So what's left is, when you think about it, you got SO2 left and CaO left. So sulfur dioxide makes what anion? Sulfide anion. So my guess is you can make calcium sulfide. And the word is suggest, so they need you to work it out. Not that you've learned it, but you need to work it out. Because what's left is sulfur, oxygen, and calcium. So calcium, sulfur, 3 oxygens makes most likely this product. Because you've seen sulfur dioxide, you've seen sulfide, you've seen calcium, so they thought that you can figure that SO2 becomes SO3 2 minus and calcium 2 plus makes the salt calcium sulfide. But which is why it's also only 1 mark. If you get it wrong, they're okay with it. Then state and then explain for 2 marks. 1 mark for state, 1 mark for explain the effect of increasing temperature on the rate of reaction. So when you increase temperature, you say, what does increasing temperature do to the rate? That's 1 mark. Increases rate of reaction. That's 1 mark. And why is the primary to second pollutant? I don't really care that much. So rate increases, okay. And why does the rate increase? Because you can say particles have greater energy. Therefore, what does that mean? Therefore, more particles have energy greater than activation energy. That's what it is. More particles. Yeah, actually, just the particles might move a little bit faster. That's not the main reason. The main reason is more particles have energy greater than activation, which means the success. So basically, therefore, frequency of successful collisions increases. Overall collisions don't increase by much, but successful collisions increase by much, because more and more of them are successful now, because these guys have more energy than activation. So if they collide, now they'll react. Before, they would react and might not collide. They might collide but might not react. Now they collide and definitely react, because they have more energy than activation. So just increasing kinetic energy is not the answer, guys, please. That's like part of the answer. The real answer is that more collisions that are successful, because they have energy greater than activation. More successful or effective collisions. Collisions are the same almost, but they are more successful now. And then the last bit is, so when you use lumps of calcium carbonate, then powder, what happens when you use lumps? State, well, the rate now why will the rate decrease? Because there is surface area decreases, therefore क्या कहते हैं, there is a decrease in collision frequency between what was that? SO2, right? Because if less surface area, there is less particles exposed, so surface area decreases, less particles exposed, so the frequency of collision decreases. The particles might be moving, but they're not hitting each other as much, because there's not less calcium carbonate available to hit, and that's why. Yes, you're right, Shayan, absolutely. That is true. Now, that's this. The next question is about period 7, or group 7 or 17, either or, how we call it, that's what we are looking at. So, what do we have next? The melting bromine is in group 7, and the melting point is -7, and the boiling point is 59. So above 59 it's a gas. So why is it solid at well, because it's -50 degrees is lower than its. They just wanted people to know, because if you draw a number line, guys, to make life easy to understand, you got 59 degrees and you got -50 and -7 somewhere here. So above 59 is gas, below 7 is solid, and between is a liquid. So -50 is below melting point, hence it's a solid. Okay, so describe. So now here you have to describe the arrangement and motion. So the arrangement is a what? What's in a solid? Solids are Particles are the, you can say, molecules arranged in a regular lattice or a regular lattice very close to each other, hardly any gaps, and they vibrate. That's a solid. Vibrate basically in that fixed position. What you're doing is you're describing a solid right here. Solids are a regular arrangement, particles are very close to each other, and they vibrate about their position. Shayan, I don't know if that's a question or a statement. Absolutely, Shayan, that's the answer. You know everything, Shayan. I think maybe you can teach my next class. You're good boy. That's right, absolutely on spot. Okay, moving on. Then a sample of bromine contains this many molecules. 1 mole contains this many molecules. So what you do is you find how many moles this is, and then you multiply by mr, because bromine is Br2. So you first find the number of moles. Number of moles is the number of particles divided by Avogadro's number. How many moles do I get? When I do this, I get about 40 moles. And the AR of bromine in the periodic table, the AR is 80. So the MR would be 80 times 2, which is 160, because it's Br2. So the number of moles is mass over molar mass. So 40 equals to mass over 160. And so 40 into 160 is your answer, which is 6,400 grams. All right, capiche? Make sense? Now we have redox. This is fun, by the way. So the redox of a neutral, this guy is 0 and this is -1. And if you're wondering what's the oxidation state in bromate, I want to do that too. It's Br. I can never write my BRs. BrO3 minus. In that case, Br is unknown, oxygens are -2, and the overall charge is -1. So x minus 6 is -1, x is 6 minus 1, which is 5. So in this fellow it's +5. In this fellow this is -1. So during this reaction bromine is reduced just by looking at this, by the way, and explain in terms of electrons. So you see Br2 gains electrons to become Br minus, and gaining of electrons is reduction. Oxidation is loss of electrons and reduction is gain of electrons. Yeah. Now the next part of the question is about equilibrium. So bromine reacts with hydrogen in a closed system to form an equilibrium mixture. Br2 plus H2 becomes HBr. The temperatures increase, the pressure remains constant. It's saying the forward reaction releases thermal energy. That means the forward reaction is exothermic. So when I increase temperature, they're not talking about rate. When you increase temperature, we'll talk about what happens to the position later, but let's explain it first. So when you increase temperature, okay, as you can say increasing temperature is fair. So increasing temperature favors endothermic reactions, and the backward reaction is endothermic because the forward is exo, so the backward reaction is endothermic. So here the reaction will go backwards, so the position of equilibrium moves backwards, or you can say what is backwards, moves to the left. Left is backwards, right is forwards. It favors the left hand side, but don't just write LHS, write the whole word. And the next part is about pressure. So the pressure is increased. Now what does the pressure has to do with the moles of gas, but the problem here is the left hand side has 2 moles of gas, the right hand side has 2 moles of gas, and pressure so the pressure will move to the side where are fewer moles of gas. Okay, so pressure increases favor what sides? Favor side with fewer moles of gas, but here both sides have the same number of moles of gas. What does that mean? So therefore there is no change in position, because there's no, each side is the same. Cheyenne, you too good, dude. Too good. Oh, my writing is readable. Okay, and a bromide of phosphorus has this many mass by phosphorus, and they want the empirical formula. So phosphorus and bromine. So phosphorus is 7.2, bromine is 100 minus 7.2, that is 92.8. This is by mass. By moles, you divide by the atomic mass, which is 31, and this is 80. So I can take it here also, show my working, and I can take it here. And I'm showing my working. So what does this amount to? This amounts to 0.232, and this amounts to 1.16. Then you divide both by the smaller number. You get 1 is to approximately 5. So the formula is PBr5. Nice fun question. Easy part, last part. All right. I'm going to do only one next question. Do I do electrolysis or organic chemistry? Quick, tell me. I only have time for one question left. So electrolysis or organic? Okay. Cheyenne organic. I had that one open. I figured it's a longer question anyways. Okay. So here we have organic. Let's start this question. So this guy is, if you can look at the functional group, it has two functional groups, by the way. If you can see, one is this OH and one is this COOC. This OH makes it an alcohol and this makes it a ester. So it's an alcohol and it's an ester. Is it telling you? Now why is it saturated? It's saturated because all, you can say, carbon-carbon bonds single, meaning don't say it only contains carbon-carbon single bonds. That's tells me that it doesn't contain carbon-hydrogen single bonds. You should say all the carbon-carbon bonds, only those bonds are single. That's why. The wording makes a big difference, Cheyenne. If he says it only contains carbon-carbon single bonds, that tells me it does not contain carbon-oxygen single bonds. But it does. It also contains carbon-hydrogen single bonds. It also contains carbon-oxygen double bonds. But what we want to say is that all the carbon-carbon bonds in the whole molecule, they are single. That means there's not a single carbon-carbon double bond. Now why is it an alcohol? Because it contains the OH functional group. Why is it an ester? Because it contains the which bond? The COOC, you can say, functional group or bond sequence or linkage, whatever you call it. COOC. The C matters because if it is an H, it will make it an acid. Now here they are a pair of isomers, they're saying, because if you count the formula, let's count the formula. When you have isomers, it means that they have formulas, the molecular formula is the same. So now look at A, I've got 1, 2, 3, 4 carbons. I've got 1, 2, 3, 4, 5, 6, 7, 8 hydrogens, and I've got 3 oxygens. C4H8O3. No, Cheyenne, that's not the right answer. It does not have carboxylic acid. It has an ester linkage. This guy has carboxylic acid, but they're not asking. They're asking why the isomers. The isomers happen from formula. So that's 4 carbons, 1, 2, 3, 4, 5, 6, 7, 8, and oxygens 1, 2, 3. So both A and B have the same molecular which one? Okay. I don't know what Muddik is studying about ketones. It doesn't have a ketone, neither do study ketones in IGCSE row level. So that term is never used in O level or IGCSE chemistry, please. Yeah. Then This is compound C. It's another ester. It's made up of reaction with alcohol and carboxylic acid. So when I want to identify, the C double bond O part comes from the acid, and the other part, come on, this part comes from the alcohol. So, and there's a catalyst. So what's the catalyst? Whenever you're doing esterification, what's a catalyst? Name the type of a catalyst used in this reaction. It's an acidic catalyst. It's an acid. It's a concentrated acid. The alcohol has 3 carbons. So it's 3 carbons with OH on the first carbon. This is the alcohol. You know what alcohol this is? This is propan 1-ol. And the acid is a 1 carbon acid. What's a 1 carbon acid? Methanoic acid. How? Because it's just this. And that must have been the OH. So I combine them at the bottom. No, not vanadium 5 oxide. Ibrahim, vanadium 5 oxide is used to convert SO2 to SO3. Just because you heard the word catalyst doesn't mean that's the catalyst. Esterification uses acid catalysts. So the alcohol, we've drawn it above. It is propan 1-ol. And the rest of the H's go here. H. That's formaldehyde. You know, Mudek, this is an O-level paper, right? What is formaldehyde? Formaldehyde is not here. I don't know who's teaching you all these things, but that's not here. Formaldehyde is not even close to what we have here, just because it has 1 carbon. This is an acid. Yeah. So, now there are 2 monomers for a condensation polymer. You got a this is a diacid, and this is a diol. So, well, let's take the diacid first. So you remove the OH of the diacid, and then you have CH2. CH2. I don't need to show all the bonds. CH2, CH2. I mean, I can draw all the bonds also if you are interested. So make it the same. This is just me drawing the acid after because acid to make an ester loses the OH, and the alcohol to make an ester loses the H. So the alcohol is O, bonds to the CO of the acid to make an ester, and the condensation polymer is a polyester. So the bonds are all ester, and so this is 1 unit. Then what will happen is this orange fellow will come right here, and then a green fellow, and an orange fellow, and a green fellow, and an orange fellow. Yes, it might be Mevolakhani, but sure, I'm glad you can figure out it's a diacid, but we don't need to know the names. An equal number of monomers of D and E are reacted to make condensation polymer. The total mass of monomers D and E is 80. And why is the mass of the polymer less than 80? Because water is also made. Because water is formed and given off. Okay? You can say water molecules are formed as byproduct and given off. So the mass decreases. That's what we have there. All right, I'm done. Thank you very much for your time, people. This has been good. This has been really nice. We'll see some more sessions soon for sure. Okay. Thank you for joining. This has been a pleasure. Easy question paper. All right. Till the next time. Hasta la vista.